100 grams of water at 25 degrees Celsius is poured into an insulating cup. 50 grams of ice at 0 degrees Celsius is added to the water. The water is stirred until the temperature of the water has fallen to 0 degrees Celsius. 15 grams of ice remains unmelted. You have to calculate the specific latent heat of fusion of ice in this question. The first thing that you need to understand is that the 100 grams of water, which is at an initial temperature of 25 degrees Celsius, is losing heat. Why is it losing heat? Because the temperature falls from 25 degrees Celsius to 0 degrees Celsius. You keep stirring the water until the temperature of the water has fallen to 0 degrees Celsius. If the water is losing heat, then that means the ice is gaining heat. Okay, the ice is gaining heat, but the temperature of the ice remains unchanged. You can see that the ice was at 0 degrees Celsius and the final temperature of the mixture of water and ice is also at 0 degrees Celsius. Then what does this heat gain do? You can see that 18 grams of ice remains unmelted. That means the remaining 32 grams of ice has melted, and the heat that the water has lost is used to melt that ice. So always remember, theta is equals to mc delta T is specific heat capacity, and this is used for changes in temperature. Theta is equals to ml is the formula for latent heat, and this is used for when the temperature is constant. So the change in temperature is for water, so this formula I'm going to use to calculate the heat lost by the water. So theta I need to calculate, which is heat. The mass of water is 100 grams. The heat capacity you've been given is in grams per degree Celsius, so I'm not going to change the mass. It's going to be 100 multiplied by the heat capacity of water, which is 4.2, into the change in temperature, which is 25 degrees Celsius. So this, from here you get 10,500 joules. So 10,500 joules is the heat energy lost. Obviously, in heat questions, always remember heat loss is equals to heat gain. This is an assumption that you make. Then that means if the water lost 10,500 joules of energy, then the ice gained 10,500 joules of energy. But because the ice is at constant temperature, the formula I'm going to use is theta is equals to ml. Theta I have calculated, which is 10,500. Mass you're only going to take of the ice that has melted. So only 32 grams of ice has melted. So I'm going to take mass as 32. And latent heat I need to calculate. From here you get 328.125, which is approximately equal to B.